Hello, my name is Ben Palmer along with Colin Sowards and Steve Sainsbury. This Pachachka video presents a product idea we think would be successful in the market based on the technical and marketing research we've prepared. The purpose of our heated driveway and sidewalk is to relieve the worries of snow removal and icy slippery conditions at an affordable rate for a large customer segment. Our product can be used by anyone who lives in a region with winter conditions such as snow buildup and freezing rain. This design is better than most like it because of its efficient power usage, long-term value, and unique personal settings that allow the user to program it in accordance with the temperature or as they wish. Our product will solve the problems of snow buildup and potential damage to the customer's driveway. Our technology works by taking advantage of a temperature sensor and displaying the driveway temperature value on an LCD screen. More or less current is sent to the heat cable system underneath the driveway in accordance with temperature values. The real-world system uses a temperature sensor for accurate precipitation predictions, a transformer to amplify the current flow, and an inverter that changes the current from AC to DC for the heat cable. In our final design, not only will the system change current flow according to driveway temperature, but the user will be able to manually shut off or modify the heating system. The Arduino replication of the real-world system uses a large LCD screen that displays current temperature values received from the TMP36 sensor. The blue LED changes brightness in accordance with temperature change, simulating the heating cable in the real-world application. Now, as you can see, the blue LED is fairly bright at room temperature. Our goal was to make the LED brightness symbolize the amount of current, which is directly proportional to the temperature going to the heating element. In order to demonstrate this idea, we unplugged the positive side of the temp sensor to give the circuit a false reading of over 400 degrees Celsius. As you can see, this results in a very dim LED or a very small current flow. Conversely, if we unplug the ground sensor on the circuit, it reads a temperature of around negative 50 degrees Celsius. This makes the LED even brighter than at room temperature. Thus, the hotter the temperature is, the less current and heat the driveway receives, and the colder it is, more current and heat is sent to the element to make up for the loss in energy due to the outside temperature.
Miller Welding Company introduced fast switch inverter technology. This allows for products, welders from Miller, heating cable for us, to operate at a frequency of 100,000 Hz, which is 2 to 5 times faster than existing inverter technology. These inverters are also convenient as they are much smaller, more portable, and lightweight. We will take advantage of this technology to make our heated driveway setup be even more effective and efficient. Using an inverter with such a high frequency also allows us to use a relatively smaller transformer. This will greatly reduce our costs as a business. Transformers take high voltage, low current from primary power, the utility, and transform it to a low voltage, high current system. The high current helps the heating cable heat more, faster, while the low voltage keeps your power use at a minimum. All in all, we will boost our heating effectiveness and use less power from the utility with a transformer/inverter combination like what Miller is using for some of its new welders. Our performance specs include power usage and cost predictions for our product. We researched that it would cost roughly 12 cents per kilowatt hour per 100 square feet of heating cable based on the national power cost average. According to our calculations of heating a 500 square foot driveway, an average that we picked out, it will cost $14 to run our product for a full day. We realize that the system will use more power on cold days, but this is an average value with the warm days also taken into account. With that said, our inverter and transformer will effectively decrease this power cost value down. We can't provide these values at this time simply because we aren't able to find a data sheet for a specific transformer/inverter setup that would be even close to what we would use. We concluded that safety is paramount for our customers, whether it's for residential or business purposes. Our product eliminates customers' fears of hazards like icy sidewalks and driveways, in addition to snow buildup, which saves time and money. The data on this slide represents our initial scores from our preliminary assumptions of the value of our product as designed by the Josh Kaufman Quick Test. With a total score of 77 points, we decided to proceed with our product idea. There are several similar products on the market that rely too much on expensive features. Geothermal heating is a great example. It will cost $20,000 to $25,000 for installation alone, almost 3 times the cost of what our product will. Another advantage of our electric-based product is the ability to manually shut off the system. A geothermal system is continuously pumping water, so regardless if you are heating the water or not, you're paying to run the pump. The advances in technology on our product relate to the need to acquire, as humans consistently are looking for new, high-tech products. Our product represents a dedication to providing not only a convenient but also a high-quality service to customers that integrates outstanding technology as well as ensuring safety and satisfaction. Overall, our product provides a higher state of living.
This is our pro forma income statement. On it, we estimated some of our initial figures, such as the number of units sold per year and the price of each individual unit. We were able to create a basic math model for the rough cost to produce and install our product, as well as an average cost to operate the unit thanks to the data of national averages for similar products. We have included the complete statement in the assigned PDF document. Our assumptions included that we were installing a heated driveway and sidewalk of 500 square feet. We calculated this to be right at $7,500 at a price of $8,000 per install, multiplied by 1,500 units sold per year. That is a $12 million in sales revenue. Estimating the cost of goods to be $6,600,650 a year, and our selling and general administrative expenses to be $4,667,750, we determined our net income to be around $829,800 per year. We did an SII, or Strengths, Improvements, and Insights, as part of our project reflection. Our 3 strengths were the ability to finish deadlines, developing critical knowledge in construction, and solid teamwork initiative. Our improvement included use of time, better communication, and better project planning. As a result, our insights led us to the conclusion that better dialogue keeps a group working together and eliminates confusion. Our lessons learned included taking into account the physical location of our business. For example, the market for a heated driveway system is going to be ridiculously low for people in Texas. However, it would be substantially higher for folks in Wisconsin or Minnesota. We also learned that our product must be something that people would want and buy. Lastly, we learned that a solid technical design is integral for creating a product that is both user-friendly and cost-efficient. A heated driveway or sidewalk is a great product for those who don't have the time or desire to manually remove snow and want to keep their driveway undamaged. We're able to provide a unique product design that is more efficient than what is currently on the market, while saving money and prolonging the life of their driveway in addition to keeping the consumers safe.